Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 7, Notes 5. So we're talking about arcs and chords. So today we're going to be learning about the difference between the two and how we can use the two to kind of find measures of certain parts of a circle. So let's go ahead and let's take a look. So the first theorem we need to do. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So what we're saying is that if we know that FG and are congruent, then GH and FG, the chords, are congruent. So if we know that the chords, so the line segment FG is congruent to the line segment GH, then we know that the chord, or the arc, so now to represent the arc, I'm going to draw a little arc over it, is congruent to JH with an arc. Okay, so that's something we can use moving forward. So let's take a look at an example of that. So for number 1, in an embroidery hoop, AB is congruent to CD. So that means that this arc is also 60 degrees. It wants us to find the measure of CD. Well, I just did. If AB is congruent to CD, the line segments here, if this is 60 degrees, then this is 60 degrees. So the answer for that one is 60 degrees. Let's take a look at this next one. In the figure, circle J is congruent to circle K. Arc MN is congruent to arc PQ. What does that mean? That chord MN is also congruent to chord PQ. So that means that 2x plus 1 is equal to 3x minus 7. So now we're going to solve that for x. So since this is a positive 2, I'm going to go ahead and subtract 2 from both sides. So then I get 1 is equal to x minus 7. And then I'm going to go ahead and add 7 to both sides, and I get that x is equal to 8. Okay, so for number 2, x is equal to 8. That's not all of what the question's asking. It's asking us to find PQ. So I actually need to plug in 8 for x. So I have 3 times 8 minus 7. 3 times 8 is 24. Minus 7 is going to be equal to 17. So that's your final answer for number 2. Next, let's take a look at number 3. In the circle W, we know that RS is congruent to TV. So again, that means that our chords are congruent. So 5x minus 9 is equal to 2x plus 3. So here's my smaller amount of x's. So I'm going to go ahead and subtract that over to the other side. And then I get 3x minus 9 is equal to 3. So then I'm going to go ahead and add 9 to both sides. So I get 3x is equal to 12. Then I'm going to divide both sides by 3, and I get that x is equal to 4. So now I need to find RS, which really is the same as TV. So I'm going to plug in for my x. So 5 times 4 minus 9, so I can get that RS value. So then I get 20 minus 9, and that's going to give us 11. So RS is equal to 11. Let's take a look at another theorem involving arcs and chords. Okay, so for theorem 10.3, if a diameter or a radius of a circle is perpendicular to a chord, so here's our chord here, and it's perpendicular to our diameter, okay, then it bisects the chord and its arc. So that means that this is congruent to this, and this is congruent to this. Okay, so that's going to help us in the future. But in order for this to be true, we have to have that perpendicular angle. We can't just have them crossing any way, shape, or form. It has to be perpendicular in order for it to bisect. Remember that bisect means to cut it into 2. Let's take a look at theorem 10.4. The perpendicular bisector of a chord is a diameter or a radius of a circle. So that's kind of like the reverse. So if we know that this is perpendicular and that those two are congruent, that means that this line is either the radius or the diameter. If it was only half of this, if it was just this part right here, then it would be the radius. But you see AB extends all the way through, so it has to be the diameter for that one. So let's take a look at putting this into practice. So in number 4, for circle S, PQR, so this entire thing is 98 degrees. Not the band, just the measure. Okay, so it's 98 degrees. So we want to find the length of PQ. So what I notice is that SQ is perpendicular to PR. So that means that SQ bisects that arc. So those two are equal length. So to find PQ, all I have to do is take 98 and divide it by 2. And then I get 49 degrees. So that arc length in degrees is 49 degrees. Now we want to find PR. So what do we know about PR? Well, it's this whole length right here. I know that this side right there is 6. Well, guess what? This side over here also has to be 6. Okay, because again, that radius bisects it because it's perpendicular to the chord. So PR is going to be 6 plus 6, which is 12 for number 5. Let's take a look at number 6. In the circle J, the diameter is 30 inches, so this whole thing is 30 inches. KM is 22 inches, so that means that KL is 11, and we're trying to find JL. Okay, so if we know the diameter is 30 inches, they kind of drew this little light dashed line in there. Well, this light dashed line is a radius. Do you see how it extends from the center of the circle to the side? That means it's a radius, which means that it's the length 15 because it's going to be half of the diameter. So since this is perpendicular, I now have a right triangle. So I have 11 and I have 15. And so then my X is there. So then what I'm going to do is I'm going to go ahead and I'm going to solve this using the Pythagorean theorem. So I have 5 squared is equal to x squared plus 11 squared. So then I get 225 is equal to x squared plus 121. And then I'm going to subtract 121 from both sides. And then I get that, oops, that's a funny looking 2. X squared is equal to 104. So then I'm going to take the square root of both sides, and I end up getting x is equal to 10.20 inches. Again, you want to label it because they gave us a label in the problem. So x, or JL, is 10.20 inches. Let's take a look at our next theorem here. So in the same circle, or in congruent circles, two chords are congruent if and only if they're equidistant from the center. So that means that this chord is congruent to this chord only if these two parts are congruent. If that's true, then this is congruent to this. So it's really important that you have these theorems when you're taking your quiz so you can look at them and they can kind of help you through that quiz. So let's take a look at this. In circle A, WX is equal to XY is equal to 22. So these two chords are congruent at 22. Well, since we know that both of these are 22 and they're congruent, then we know that this right here is congruent to this right here. Okay, so they're equidistant from the center. They're the same distance from the center because they're congruent. So then I have 5x is equal to 3x plus 4. So now I'm going to bring this 3x over to the other side, so I'm going to subtract it. And then I get 2x is equal to 4, divide both sides by 2, and I get that x is equal to 2. Now the question is asking us to find AB. So I need to plug in 2 for my x, and 5 times 2 is 10. So AB is the distance of 10. So that concludes your note video today. Go ahead and show me your note sheet when you're done. Thanks for listening.